Let us explain how a three-layered gastrula is formed. At first, we again use the view on the floor of the amniotic vesicle. This time upwards is the cranial pole. Here would be the caudal pole. So we know that there is a thickening of the epiblast. In the midline is the primitive streak, which ends with a primitive node, and we got the notochordal process growing below towards the precaudal plate of the yolk sac, right? All these this amniotic vesicle is embedded within the extra-embryonic mesenchyma, and here perhaps would be the section through the allantois of the yolk sac. So this is the view on the floor of the amniotic vesicle with the primitive streak ending with the primitive node, from which the notochordal process grows. Towards the precaudal plate that already belongs to the yolk vesicle, and so does the allantois yolk vesicle. It's all surrounded with extra-embryonic mesenchyma. Now the new thing here is that the cells from the primitive streak, from the epiblast of the amniotic vesicle, is migrating out below the epiblast, thus forming the mesoderm. And the migration waves will also continue cranially, by the way. So this is the migration of mesoderm. And this time it will be the intra-embryonic mesoderm, okay? Intra-embryonic. Let's make a section to elucidate this. Let's make a section here, a transversal section, and look at it once more from a different perspective. From a perspective of transversal section, you would see the amniotic vesicle, its floor somehow thickened, because the cell populations are growing there, and they become the source of the intra-embryonic mesoderm that migrates below, as suggested already here. Then we got the yolk vesicle and a transversal section, and a population of cells that becomes thicker here, responding to the proximity of the amniotic vesicle. That's the caudal mesodermal plate, and all this embedded within the extra-embryonic mesenchyma. Undifferentiated connective tissue. Okay, so this is the extra-embryonic mesenchyma, sometimes in some textbooks also called extra-embryonic mesoderm or primary mesoderm. So just to avoid confusion, I would prefer using the word mesenchyma because it better characterizes the composition of the tissue, which is really a mesenchyma. This is the thickening of the epiblast. Which will become the ectoderm. This is the migration of the intra-embryonic mesoderm. This is the chordomesodermal plate. The interaction between the yolk and amniotic vesicle. That will later on become independent and form the notochord. This is the hypoblast that will become the endoderm, and this is the amniotic vesicle, and of course the yolk vesicle. As seen on transversal section. So how does the gastrula look like? Finally, we got the amniotic vesicle with the embryonic ectoderm on the dorsal aspect of the body. We got the yolk vesicle with the embryonic endoderm on its roof. This chordomesodermal plate will become independent and will form the notochord as the central axial structure, on both sides of which the mesoderm will be organized. And we can distinguish kind of three populations of mesodermal cells with different fate. The most central here, then kind of a connecting part, the intermediate part, and the lateral part, which splits into two layers. One that follows the amniotic vesicle and another one that follows the yolk vesicle. On the other side, it will be the same. So let's label the structures. The amniotic vesicle. Now we have the ectoderm, the first, the outer germ layer. Then we got the notochord here. on both sides of which the mesoderm, also known as the middle germ layer, and the mesoderm, we can distinguish kind of three populations. I will label it 1 here. This is the closest to the notochord, and it will be the paraxial mesoderm, and it will become segmented into body segments called somites. That's why it's sometimes also called somatogenic mesoderm. Another population, this labeled 2, it's called intermediate mesoderm, and we will come back to that when discussing the development of genital and urinary system, because this will form the so-called nephrogenic cord that runs through the body and gives rise to some organs of the urinary system. And the most lateral part that splits into 2 layers, 3A and 3B. So it's the lateral plate mesoderm, which consists of a layer that runs along the amniotic vesicle. This is called the somatopleuric mesoderm, and another plate or another layer that runs along the wall of the yolk vesicle. Well, this is the yolk vesicle, right? And the layer of mesenchyma that adheres to that is called the splanchnopleuric mesoderm. And this is the trilaminar gastrula with, well, it's supposed to have 3 layers, so I've forgotten the innermost that lines the yolk vesicle, which becomes the endoderm, the inner germ layer. Okay, now we got these 3 germ layers forming the trilaminar gastrula, which still does not resemble the body form of the future embryo. It's kind of a flat disc, but in the next step we'll explain how this is transformed into something that already resembles the anatomy of human body.